Today will be a recap of counting, permutations, and combinations. Our objective will simply be to practice problems using all three of those methods. The reason I want to do this is because many of you will do okay with counting problems when that's the only type we have. You'll also do okay with permutations as long as that's all we have, and with combinations. But when the three get mixed together, sometimes you have trouble making a decision which method to use. So that's what this lesson is about. Our first application will be a parade. A parade consists of 5 floats, 2 marching bands, and 1 group of horses. How many different ways can they be lined up to parade? The first question you have to ask yourself is, does order matter? Does the parade look different if the horses come first and then the marching bands? Or does it look different if you have a float and then a band and then the group of horses? And the answer to that is yes. If it's a Christmas parade, you may want Santa to be at the end. So it does matter how you line them up to parade. So the first thing you need to make sure that you understand is that this is a permutation. It's a permutation of how many things taken how many at a time. So the first question is, how many things do we have total? And the answer to that is 8. How many of them are going to be in the parade? All 8 of them. So it will be a permutation of 8 things taken 8 at a time. On the calculator it would look like this. And I do want to remind you, you could have done that problem by saying, I have 8 ways to choose the first item, then 7, then 6, down 3, 5, 4, 3, 2, 1. That would have been the same as 8 factorial, which would have also given you 40,320. Either way is equally good. Let's continue now with a lottery problem. In a certain lottery, the player chooses 7 numbers from the numbers 1 through 47. In how many ways can the 7 numbers be chosen? In this one, order does not matter. All he's got to do is pick the right 7 numbers. So it's a combination, not a permutation. So it's a combination of 47 things taken 7 at a time. On the calculator, it looks like this. This one cannot be done by saying how many ways can I choose the first number, how many ways can I choose the second number. That can be done on permutations, but not on combinations. This is the only way we have of getting the answer on a combination. Let's look at another problem. This time we'll be examining a menu. For $3.98, a person can get a salad, a main course, and dessert at the cafeteria. If you have a choice of 3 different salads, 3 different main courses, and 4 different desserts, how many different meals can you get for $3.98? This is just like building the car problem. How many choices are there for the first thing? 3 salads. For the second thing, 3 different main courses. And for the third thing, 4 different desserts. 3 times 3 times 4. So a total of 36 different meals that can be built using only the fundamental counting principle. Application 4, we have a health inspector. A health inspector must visit 4 of 14 restaurants on Monday. In how many ways can she pick the 4 restaurants to be visited? Notice there's no indication of what order she's going to visit the restaurants. It's just a matter of which 4 are going to be visited. Therefore, order does not matter. It's a combination. A combination of 14 things taken 4 at a time, for a total of 1,001 ways to visit those restaurants. That one is a combination. I'm going to change the problem just slightly now. A health inspector must visit 4 of 14 restaurants on Monday. In how many ways can she pick a first, second, third, and fourth restaurant to visit? This one is a permutation because there's an order that she's going to visit them. At this time it will be a permutation of 14 things taken 4 at a time. Are you going to have more choices or less choices? You're going to have many more because restaurant A, B, C, D is different if it's C, B, D, A. On the calculator it looks like this, and we get 24,024 choices. This one could also be done, don't forget, as 14 times 13 times 12 times 11, which also gives me my 24,024 choices. And our last problem deals with committees. How many different committees of 3 can be selected from a group of 8? It's a combination of 8 things taken 3 at a time. Calculator looks like this, and you get 56 choices. or 56 different committees. Change the problem just slightly. How many different ways can a president, vice president, and secretary be selected from a group of 8? I still have the same group of 8, but this time it matters. If Joe's the president, Sam's the vice president, and Tom's the secretary, that's different than if Tom's the president, Joe's the vice president, and Sam's the secretary. Order matters. This one is a permutation. 8 things taken 3 at a time for a total of 336 ways to choose those, or a choice of 8 ways to choose the president, 7 ways to choose the vice president, 6 ways to choose the secretary, also for a total of 336 ways. I hope that this lesson helps you nail down a little bit the differences between permutations and combinations. So that's all I have for you today. I'll see you again soon. Bye-bye.